Step 2 of hypothesis testing that we will do is determine alpha. Now, recall that alpha is sort of the other side of the coin of the confidence level. And so recall that if you have the 90% confidence level, that corresponds to alpha is equal to 0.10. Remember that confidence level is typically given as a percent. Alpha is not given as a percent. Alpha is given as a decimal. And so even though you may think 10% all you want, you should write decimal. 90% confident at level, alpha is 0.10. If we're at 95% confidence level, what does that correspond to? Alpha corresponds to 0.05. And if we're at 99% confidence level, that corresponds to alpha equal 0.01. The overwhelming majority of hypothesis tests done at this level of study, the overwhelming majority of these are one of those three. And of those three, the overwhelming majority is 95%. Anything that we do in this course, I will ask you to do 90%, 95%, or 99%. Occasionally, the problem will simply just give you alpha outright. Occasionally, the wording of the problem will simply say, use alpha equal 0.10. Sometimes, in fact, that's very common. You're just given alpha explicitly. Usually, for various fields of study that you'll go into, there is sort of a standard alpha to be used in this field. For us, it will typically be strictly given, either outright given like this, or it might say use 90% confidence level. For our purposes, here's a big deal. For our purposes, if no value for alpha is given, assume alpha equal 0.05. That will be our default setting. If there's no value for alpha given, we will assume alpha is 0.05. So if there's no alpha given, don't come asking me saying, well, there's no alpha given, what do we use? That's part of the question. Do you know this piece of information? If no alpha is given for our purposes, we will assume alpha is 0.05. The only time we would not use alpha as 0.05 is if a different number were explicitly given. There's much more we could talk about with alpha, what it represents, and some other details of it. In the interest of time, we're going to forego that at this level of study. I will say this, extremely crudely speaking, this is extremely crude and rough, and I'm hesitant to say it on the internet because it's not strictly speaking accurate, but this is a very, very rough and crude way to think of it. Roughly speaking, it's a measure of the probability that the hypothesis text structure is not correct, that our decision, if we reject that null hypothesis, is not correct. That's an extremely crude statement of it, but that's roughly speaking what's happening here. It's a measure of the error, the potential error involved in one type of potential error in this problem. And so if we use alpha 0.05, roughly speaking, that means that if another researcher did the same experiment using the same structure and the same value, the same structure, the same parameter values, if another researcher did this, then roughly speaking, we're saying that 95% of the time, the same result would arise. Again, that's not strictly accurate. There's more to it than that, but that's the way to think of it. So for our purposes, determine alpha, one of two things. Either it's going to be given, it might be given this way, it might be given this way, but it's going to be given, or it's not going to be given. If it's not given, then we assume alpha is 0.05 and go merrily along our little way.